Hello beautiful people, this is Ash back after a long time. It's been a really busy month, but here I am back. And today I'm going to do something that closely associates with electricity and magnetism. It's more like a demonstration, and believe me, we have all done this kind of stuff when we were in high school. The least we have done is we take a motor and couple it with a battery and we make it run, and we were taken with awe, and we felt like saying I'm something of a scientist myself. So today I'm going to do something that is about motors. So let me just talk about motors before that. So this is a standard motor that I stripped out from a toy and stripped all its wiring out. So this is the coil. You see this? Of course, this thing has a lot of wires around it, but I stripped the wires out, and this is the iron core that is just used to enhance the magnetic field. I'll come back to this later. And this is the other body, the container. And if you see closely, you can see two permanent magnets inside. You see, one up and one down. So now what happens is a motor works due to the interference of two different magnetic fields, one from the permanent magnet, and the second is the magnetic field generated by the coil when you pass electricity through it from the battery. And the iron core just strengthens that magnetic field. So this is a standard motor, and any other motor or even generators have two different magnetic fields. And in one of my previous videos I talked about different kinds of motors and generators. It was about Andres the one Jedlik. Okay, so there was something called self-excitation where okay, I don't want to go into the details anyway, just check out the video anyway. And here's a motor. So there are two magnetic fields. So we use two different magnets, one a permanent magnet, another an electromagnet. But there is something that breaks this principle. What cannot be broken is the fact that we need two different magnetic fields. So what we do is we take a permanent magnet. I take these things. I call these disc magnets. Okay, these are the strongest magnets commercially available in the world these days. This is an alloy of neodymium, iron, and boron in the FeB. These are really strong, really strong, and really fragile as well. The unique point about these magnets, as compared to the other commonly available magnets, is that these magnets actually conduct electricity, and that is what makes these things useful in the present scenario. Okay, so we need two different magnetic fields. We have one of them, and I'll use only this magnet, no other magnet at all, to make a sort of a motor. And if you want to recreate the demonstration, let me just tell you, you can buy this kind of magnets easily. It's also available on Amazon or like other places around you. I recommend you use a magnet which has a diameter of around 25 mm and the thickness of like 2 mm to 3 mm. That'll be good. And you'll use a screw that can be magnetized easily by any magnet. Don't use a non-magnetic screw. That will just sabotage the whole thing. So here I take the magnet, and what I do is attach the screw like this to its center. There's a magnet and the screw has been attached in its center. Okay, now the next thing is I need a battery. You can use any battery around 1.5 volts to 2 volts. I stripped this thing out. This is 2 volts. I stripped it out from some piece of machinery, and a wire. This is all we are going to need. So I take the screw and the magnet, and since the screw is magnetized because of the magnetic field of the magnet, so the screw behaves like a magnet itself, and I suspend it from the battery, something like this. You just stick it to the end and it just stays down there. You take a wire from the top end of the battery and bring it to the bottom. Can you see it's rotating? I hope you do. So you see, this thing was rotating. Now let me tell you again once again. So what happens is this whole thing rotates like this. Oh, sorry. Something like this. This magnet itself rotates and takes the screw along with it. So how does this happen? I just said we need two magnets and I just used one. What happened? What happened is I generated two magnetic fields from the same magnet. This is a permanent magnet. It has a magnetic field of its own, right? And we also know from the basic laws of magnetism that the direction of the force applied on a conductor because of this kind of interference of two different magnetic fields is directly like is in a is perpendicular to the direction of the magnetic fields. So this is a magnet. Its magnetic field is along this line. Here is a screw, and when I connect it with a wire, right, like this, there is a current that flows through the system and up to the battery. So this is a circuit. Okay, let me take the wire as well. I might as well recreate this thing. Here it goes. Yeah, good. So you see, there is a magnetic field that is emanating out of the surface of the magnet, goes towards the battery and loops it around. It's just like the wire. That is the first magnetic field. The second thing is the current that passes through this magnet because of the wire. So like I was saying, the magnetic field of a magnet, the current that is passing through the conductor, and the force in the direction in which the force is applied form the basis of a three-dimensional space. By which I mean these three things are mutually perpendicular. So the first direction, the second direction, so what remains is this third direction towards me. So this is what happens. This magnet has a permanent magnetic field and it generates a secondary magnetic field, which is because it is conducting a current. These two magnetic fields interfere with each other and try to orient the magnet in a direction along which this interference would vanish. So it just throws this magnet towards me, but it is fixed to a pivot through the screw, so it just rotates. But rotate how much ever it will, the wire keeps pumping electricity and the rotation keeps going on. So that's how this thing works, and this type of things are called homopolar motors because we use only one pole of a magnet. Simple as that. This was good for scientific demonstration, and there is a lot of science behind it. But the point is, what is the practical use of this thing? I mean, no science product is good enough if you can't really take it out and make something useful. So first thing, this can be used to make some nice showpieces to decorate your place. And other than that, the really practical use is there were some boats that were constructed to use this principle for their operation, for the propulsion to be very precise. These boats were, I suppose, used in Japan. They're not used these days, I believe. So the principle was, there was a slight difference. Okay, let me tell you more about it in some detail. So this is the surface of the boat, the bottom surface. There are two parallel slits like this, like writing an 11. Okay, and two strong magnets of the similar substance. Basically, it's the same thing. Two huge coins or plates of magnets are inserted along those slits, half inside the water and half above the surface of the boat, or actually, yeah, something of that sort. Now, next step is the two magnets are connected to some power source. Now, what happens is the power source pumps electricity to one end of the magnet, and that magnet gets charged or something. What I mean is that there is a potential difference between the two magnets, which means there is a potential difference between the two magnets and the water between them. Yeah, and water is a good conductor, of course, we all know that. So water conducts electricity. Now, what we have is where we have a permanent magnetic field which is along this line between the two magnets. We have a water which is conducting electricity in the same line. So we have these two things. The third thing is the propulsion. So what is happening is the water gets propelled. Water experiences a force because of the interference of two magnetic fields, because that is the only thing that can actually move. So water starts to loop around the magnet, and you are basically you are rotating the water like a turbine would without any turbine actually, and that propels the boat. There is another point. This thing is quite inefficient because it consumes a lot of power to give not, I mean, it doesn't give very high RPMs, so there is no practical other use to it. So these things are not really useful these days, but it makes for good scientific study because the science behind this whole thing is really, really complicated. That's it for today. Keep loving physics.